video, I am going to explain you about a combinational digital circuit encoder. Now, this is the general structure of encoder circuit. Here, it consists of, in the input side, two power n data inputs and one enable input. By using this enable input, we may found that whether any one of the input is active or not. And in the output side, it's going to consist of n number of data outputs. Now, this is the definition of encoder. An encoder has 2 power n or fewer than 2 power n input lines also we may consider. And n number of output lines. Here, the output lines generate the binary code corresponding to the input value. Now, we will consider one encoder circuit, that is octal to binary encoder circuit. Now, for this one, we are going to consider n value is equal to 3, means 2 power n equal to 8, means the number of input lines are 8 in this octal to binary encoder. And n equal to 3 means, which is nothing but the output lines are also 3 here. By considering this octal to binary encoder circuit, at any time only one input is equal to 1 here. Means, for example, here D0 means D0 input bit is 1 and leftover all other inputs are 0. This means D0 data input binary code is going to be x equal to 0, y equal to 0, z equal to 0. That means for each data inputs, we are going to generate the respective binary code in the output side. So, by this, x, y and z all are going to be 0. Now we will see next D1 input is equal to 1 and D0 is 0, D1 is 1 and leftover all other inputs are going to be 0. Means D1 data input means it is going to generate the binary code 0, 0, 1. In this manner, we may find out leftover all other 8 combinations. In this manner, coming to the combination, when D6 input is equal to 1 means that respective output data means binary code is going to be 110. And coming to the last combination, when D7 input is equal to 1 here, that respective output binary data is equal to x equal to 1, y equal to 1 and z equal to 1. Now in this manner, we may implement any encoder circuit. Now coming to the logic diagram of octal to binary encoder circuit is this one. Here it consists of 3 number of OR gates and by using this truth table of this octal to binary code encoder itself, we draw this logic diagram. Now, these are the number of input lines from D0 to D7 and these 3 lines are going to be output lines X, Y, Z. And this X is going to be found by inputs D4, D5, D6, D7. And output Y we may find by using D2, D3, D6, D7. And the output Z we may find by using the inputs of data lines D1, D3, D5, D7. Based on this truth table itself, we draw this logic diagram. Now in this manner, we may implement any encoder circuit like 4 to 2 line encoder or 16 to 4 line encoder in this manner. In this encoder circuit, we have two limitations. First one is only one input can be active at any given time. Here, coming to this truth table, at any time, only one input is active and left over all other inputs are 0. Means when one input is equal to 1, it is going to generate that respective binary code. For example, at a time, three inputs are equal to 1 means this encoder circuit is not able to generate the binary code. For example, here at a time D3 and D6 inputs are equal to 1 means by this logic diagram when D3 and D6 are equal to 1 means these two input lines are going to connect it to here this NOR gate and this second NOR gate and this third NOR gate. See here D6 line is connected to this one and here D6 line is connected to this one and this D3 line is connected to this one. Means it is going to generate the binary code here 1, 1, 1. This binary code is not representing either D3 input line or D6 input line. So, to overcome that one, we have to follow one procedure. That is, we have to give the priority for higher subscript number. In this case, when D3 and D6 both are at equal to 1 means we have to give priority for higher subscript number means we have to give the priority for D6 input line. Means when two or more number of input lines are equal to 1 means the higher subscript input line means that line binary code is going to generate at the output side. So here D6 is the higher subscript number. That respective binary code is going to be 1, 1, 0. So this binary code is going to be generated at the output side. And there is one more second limitation. This one, the output with all zeros is generated when all inputs are 0. Now, coming to this truth table, when D0 input line is equal to 1 means here it is representing 0 minterm. So, that respective binary code is going to be all zeros at the output side. That means x equal to 0, y equal to 0, z equal to 0. Means when all inputs are also 0. For example, all inputs are equal to 0. Means the output is going to generate all output bits are also 0. So here, when we are applying D0 equal to 1, at the output side we are generating the binary code is going to be 3 zeros. And when we are not applying any input value, in that case also, the output side we are going to generate the 3 bits are going to be 0. Now this ambiguity can be overcome by using valid output indicator line. Now this line we are going to introduce in priority encoder circuit. Now in the next video I am going to explain you about the priority encoder circuit. Thank you.